I'm Liwen.
We are Year 1 Actuarial Science students from Harvard University, Malaysia.
Today, we are going to teach about vectors according to SPM MAT syllabus.
Before that, please remember to like our video and subscribe to our channel.
Here are the contents that we are going to talk about. Firstly, we are going to talk about introduction of vector. Before we start talking about vector, it's important to know what is scalar and vector quantity. Scalar quantity is a quantity that has only magnitude, for example, distance and speed. On the other hand, vector quantity is a quantity that has both magnitude and direction, for example, displacement and velocity. Next, we are going to talk about how to determine its direction and magnitude. In the first scenario, the arrow is from P to Q. Hence, the direction is from P to Q and its magnitude can be calculated by using the absolute value of PQ. It's okay if you don't understand now, but you'll soon be able to understand more as you go along. In the second scenario, the arrow is from Q to P. Hence, the direction is from Q to P and its magnitude can be calculated by using the absolute value of QP. Note that the absolute value of QP is equal to the absolute value of PQ. In the third scenario, the first and second arrows now overlap each other. Hence, it is called zero vector. The direction of it cannot be determined and has a zero magnitude. Next, we are going to talk about equality of two vectors. The two vectors named P and Q with a cursive line below are equal if they have the same magnitude and direction. To recall, same magnitude means the absolute value of P and the absolute value of Q are equal, and the same direction means that P and Q are parallel to each other. In this scenario, we can see that the absolute value of P is equal to the absolute value of Q, and both the vectors are parallel. Hence, P and Q are equal. In this second scenario, we can see that the absolute value of P is not equal to the absolute value of Q, and both the vectors are not parallel. Hence, P and Q are not equal. Next, we are going to talk about scalar multiplication of a vector. The product of a vector A with a scalar k is Ka. If B equals to Ka, then vector B is in the same direction as vector A provided that k is a positive number, and its magnitude, absolute value of B, is equal to k times absolute value of A. Before we proceed, we now look at a diagram. We can see that AP is equal to PB because they are in the same direction and they are parallel to each other, hence they are equal to vector A. On the other hand, PB is equal to PA as they are in the same direction and they are parallel to each other, hence they are equal to negative A. Now, proceed with what I said just now. If k is more than 0, then A and Ka have the same direction. For example, AB is equal to KAP, which is also equal to 2PB. Hence, we can say that AB, AP, and PB have the same direction. If k is less than 0, then A and Ka have opposite direction. For example, BA is equal to KAP, which is also equal to negative 2PB. Hence, BA and AP or PB have opposite direction. If k is equal to 0, then Ka is equal to 0A, which is also equal to 0 vector. B will be equal to Ka or A will be equal to Kb when the two vectors AB are parallel and when 3 points are collinear. We are going to look at one example. The question says determine whether the directed line segments are parallel or not. To recall back, we know that the vectors are parallel when one vector can be written as a multiplication of another vector. In part A, we first write that Rs is equal to negative 6u. We then can expand it to become negative 2 times 3u. Notice that 3u is also equal to PQ. We then can write it in terms of negative 2 times PQ. Since Rs can be expressed as a scalar product of PQ, where k is less than 0, hence PQ are parallel to Rs. For part B, we can see that it's impossible for AB to be expressed as a scalar product of CD. Hence, AB and CD are not parallel. Next, we are going to talk about addition and subtraction of vectors. Addition of vectors. There are two laws for addition of vectors. First is the triangle law. In order to find what is AC, we can see that AC can be expressed as AB plus BC. Hence, it's also equal to A plus B. Next is the parallelogram law. In order to find what is AC, we can see that AC can be expressed as AB plus BC. Note that BC and AD are parallel to each other and they are in the same direction, hence they are equal. So we can put it as AB plus AD, which is also equal to A plus B. Or we can express AC in terms of AD plus DC. We see that DC and AB are in the same direction and they are parallel to each other. Hence, we can write AD plus AB, which is also equal to B plus A. Subtraction of vectors. There are also two laws for subtraction of vector. First is the triangle law. In order to find what is BA, we see that BA can be expressed as BO plus OA. Note that BO is at the opposite direction of OB. Hence, we will need to put a negative sign for it, which is negative OB plus OA. Then it will be equal to negative B plus A. For the parallelogram law, when we want to find what is BD, we see that BD can be expressed as BA plus AD. Note that BA is equal to CD as they are in the same direction and they are parallel to each other. However, for AD, we see that it's at the opposite direction of DA. Hence, we need to put a negative sign for it. So, we will get CD plus negative BA, which is also equal to A plus negative B, and in the end, we will get A minus B. BD can also be expressed as BC plus CD. Note that BC and AD are parallel to each other and they are in the same direction, hence they are equal, and we can express this as AD plus CD. Note that we only know that BA is actually equal to B, so now we need to put a negative sign for it, so it's negative BA plus CD, and we will get negative B plus A. Now, let's look at one example. It's given that OA is equal to negative 2A minus 4B, and OB is equal to 7A minus B, and OC is equal to 4A minus 2B. Now we want to find what is AB and AC. For AB, we know that AB can be expressed as AO plus OB. We know that AO is in the opposite direction of OA, hence we can express this as negative OA plus OB. Putting the figures into the equation, we can find that the final answer will be 9A plus 3B. For AC, we know that AC can be expressed as AO plus OC. Using the same concept, we know that it's also equal to OA plus OC. After solving all the values, we can finally get 6A plus 2B as a final answer. Part B, we need to show that points A, B, and C are collinear. First, we see that AB is equal to 9A plus 3B as found in part A. Next, we see that it can be expressed at 3 over 2 of 6A plus 2B, which is also equal to 3 over 2 AC. Hence, we see that AB is equal to KAC. We can then conclude that AB is parallel to AC, and ABC is a straight line and points ABC are collinear.
Vector can be expressed as a linear combination of other vectors. Now we are going to discuss the relation between vectors represented by the combination of two or more sides of a polygon. Let's consider polygon here. There are 5 vectors which are PT, TS, SR, RQ, and QP. In this case, PQ can be expressed as the addition of PT, TS, SR, and RQ. Vector can also be expressed as a linear combination of two non-parallel vectors. So for example, a vector A can be expressed as a linear combination of vectors B and C, as shown in the slide. Now, let's take a look at an example. In the diagram, EB is parallel to DC and B divides AC in the ratio 4 to 1. This means if we take the magnitude or length of AB divided by BC, it should give us the value 4. To find EB, we can use triangle law here. From the diagram, we know EB is equals to EA plus AB. Since EA and AE are in opposite direction, vector EA is the same as negative AE, which equals to negative P. And hence, we get the final answer negative P plus Q. In part B, we are asked to find DC. There are two similar triangles, AEB and ABC in the diagram. In similar triangles, corresponding sides are always in the same ratio. So EB divided by BC should be the same as AB divided by AC, which is equals to 4 divided by 5. By arranging the equation, we get DC equals to 5 over 4 EB, and we sub vector EB that we found just now into this equation, and we get DC is equals to negative 5 over 4P plus 5 over 4Q. Let's move on to the last subtopic, vectors in Cartesian plans. What is Cartesian plan? Cartesian plan is defined by two perpendicular number lines, a horizontal and a vertical line, which is the x-axis and y-axis. You'll see there are vectors I and j in the diagram here. You may be curious and ask what are them. So actually, vector I is the unit vector along the positive x-axis and j is the unit vector along the positive y-axis. How about negative x and y-axis? We can actually express them by multiplying negative 1 to be negative I and negative j. Take note that a vector of length 1 is named as unit vector. This diagram, OA, can be expressed as xy plus yj, where x and y are positive values. It can also be expressed as column vector. To find the magnitude of a vector, we can simply apply Pythagorean theorem here. Like in this case, the magnitude of vector OA is equals to square root of x squared plus y squared. And the unit vector of OA can be expressed as vector OA divided by its magnitude. Let's look at example. Given that PQRS is a parallelogram and PQ equals to 2i plus 2j and QR equals to 3i plus 4j. Parallelogram is a quadrilateral where both pairs of opposite sides are parallel. So in this case, PQ is the same as SR and PS same as QR. To find QS, which is one of the diagonals, we can apply triangle law here. We can use either QR plus RS or QP plus PS. Then we just sub in the vectors given in the question and we get QS equals to I plus 2j. To find the unit vector of PR, first we need to know the vector PR and its magnitude. PR can be expressed as the combination of PQ and QR or PS and SR. So using the same way in A, we get PR is the same as 5i plus 6j. Magnitude can be calculated using the coefficient of vectors I and j. So in this case, it's the square root of 5 squared plus 6 squared. Hence, we just use vector PR divided by magnitude and get its unit vector. So that's all for this video. Hope you guys understand and hope it has been helpful for you all. Thank you!